f of n is defined like this. I'm going to deal with that to begin with and do the integral. So it will be 1 over n, and then nx minus a half x squared evaluated between 0 and n. Sub in, I'll get n squared minus a half n squared, and then just minusing 0, which will give me 1 over n times a half n squared. I'm going to get half n. And now we've got our g of n, which is this summation here. So g of n, right, when r is 1, I'm just going to get a half. And then when r is 2, I'm going to get 1. And then it'll be 3 over 2. And I'm adding all the way up to the very last term, which will be half n. So this is an arithmetic sequence. A is a half, D is equal to a half, and I've got n terms. So although this looks quite complicated to begin with, when we just broke it down, it was just an integral, sub it in, and a relatively simple arithmetic series. We just have to deal with the fact that we are trying to find the smallest positive value of n such that g of n is greater than 150. So let's use the formula. A half times n times 2a, which will be 1, plus n minus 1 times d, which will be n minus 1 times a half, and that is greater than 150. Normally, if I was doing this with a calculator, I'd set it equal to 150, solve it, and then find the next term. But here, non-calculator, let's put the inequality in. I'm going to times through by 2 and expand the bracket, I think. So I will get... No, I'm not going to expand the bracket yet, actually. That'll be greater than 300. Now let me expand the bracket. N plus a half n minus 1 be greater than 300. Times through by 2, 2n plus n minus 1 greater than 600. So n squared minus n plus 2n, so that'll be plus n, needs to be greater than 600. This isn't going to factorize or anything. It's not going to be one of those situations, but we're interested in the smallest positive integer n such as is true. We've got some answers. I say at this point, just try things out. Now I know that 25 squared is 625, so it will definitely be bigger than 600 for that. It's just whether any smaller number would give me that. So what about 24 squared plus 24? Well, that's 24 lots of 24 plus 1 lot of 24. I'm actually going to get 25 lots of 24. And 4 lots of 24 is 100. So then I've got 6 lots of that. It's actually equal to 600. Actually, this would have factorized. So when n is 24, we get precisely 600, which means we need n equal to 25 to get above 600. That's going to be our answer. That would mean the original sum is greater than 150.